I'm going to finish this chapter, and this I will not take long classes. I'm going to discuss about the rusting. We are going to talk about the corrosion. Corrosion. See, the best example of corrosion that we have seen right from our childhood, though whatever things which happen around us we do not feel. But one example of corrosion which we have seen with whenever we buy a new pair of shoes, okay, we find the heel is like this. After wearing for some time, what happens? You find this is become like this. Is it not? You find like this. So what do you say? That this much has been corroded. This much has been corroded. This we have seen right from our childhood. Whether you buy a shoe or a sandal or a slipper, anything you wear, after wearing for some time, you find it is becoming thinner and thinner. So now from there, first we got the concept of corrosion. So what is the meaning of corrosion? Corrosion is nothing but withering away. That is, which is falling down, which was an integral part of the system. Now, gradually from there, the thickness or the substance is decreasing. This is called corrosion. Clear? Now, it has happened because of friction. But many things where friction does not occur, but still you find the substance go on losing. So every places it may not be a physical force. See, you'll find that when you when the water flows through river or stream, or too much of wind moves away, we find the portion of the stone is becoming losing its thickness. So this is corrosion has taken place because of friction. But everywhere friction does not take place. But from there you find the substance gradually falls down, and generally we observe in case of metals. Okay, so let us write down from chemistry standpoint of view. Let us write down what will be the definition of corrosion. When metals are exposed to atmospheric conditions, they react with air or water. In the environment to form undesirable substances. Usually oxides. This process is called corrosion. Thus, corrosion is withering away of a metal as a result of the reaction with air or water surrounding আচ্ছা এই ট্যাবলেটটা খালি দুই পাতাই খাইছি হ্যাঁ হালকা বস্তু আনি নিব হচ্ছে জৈব তো আমরা তিনজনে হইতে পারবো একটা একটা কে নিব আমি তাহলে মনে হয় দিও হালকা হ্যাঁ কোনো কালকে আইব
Sir, can you read out loud from thus corrosion is withering away of metal?
Corrosion is withering away of a metal. I will not write here metal, of metals. Thus, corrosion is withering away of metals as a result of the reaction with air or water surrounding them.
Thank you, sir.
Okay. Now, in case of iron, corrosion is called rusting. I should not write with capital letter, but still I am writing. It is called rusting. In case of iron, corrosion is called rusting. Okay. Now we'll get separate. Chemically, rust is hydrated form of ferric oxide. Okay. Rusting is generally caused by moisture, carbon dioxide, and oxygen. Present in air. It has been observed that rusting takes place only when iron is in contact with moist air. Iron does not rust in dry air or in sometimes this question comes, why iron does not rust in dry air? So you will write, rusting is caused by moisture, carbon dioxide, and oxygen present in air. What are the factors responsible for rusting? Iron rust. But depending upon the quality and the condition of the iron, rusting process may be faster or slow. Anyway, this is not being given in your textbook. Factors which affects corrosion. Now here we are not talking about iron, dear. We are talking about metal as a whole. See, in corrosion, chemical reaction takes place. And chemical reaction takes place means what? Metal is going to lose electron. So obviously from here, first the thing which is going to come, the metal which is more reactive will undergo fast corrosion. Metal which is less reactive corrosion process will be slow. So in that case, what you find in our house, I'm not going for those metals which you have not seen till now. I'm not talking about alkali metals. Alkali metals, I do not know how many of you have seen. I'm not talking about that. But I am talking of the metals which you have seen in our day-to-day life, in our houses. We find iron rust. Okay, iron undergoes rusting. But the ornaments gold ornaments which your mother is using, or some of you may also use, the process is very slow or hardly undergoes corrosion. Because gold is found to be least reactive, we call them as noble metal. Why? Because their reduction potential is not negative. Reduction potential is positive. But in case of iron, the reduction potential is negative. That is, they have a higher tendency to lose electron. So please remember, the first one is reactivity of metals. The reactive metal that is how you write. That is metals with negative reduction potential. Is more susceptible to corrosion. तो एग्जाम्पल क्या होगा? आयरन corrodes faster than silver or gold. Okay, next is presence of impurities. If the impurities are present in metal, the rusting process is faster. So, pure metals usually do not corrode much. The presence of other metals as impurities expedite the process of corrosion. Because This create galvanic cells. With the host metal. They oxidize the host metal to form corresponding oxides.
Sir, can you please read that sentence? The presence of
Pure metals usually do not corrode much. The presence of other metals as impurities expedite the process of corrosion because these create galvanic cells with the host metal. I'm going to explain later on. You'll see. They oxidize the host metal to form corresponding oxides. Moment the oxides form means corrosion has taken place. Okay. Then third, presence of reactive gases in air. This, I think, you might have observed because Meghalaya, many students are from village origin. You'll find rusting process is slower in village than in town. You know why? Because in town, the concentration of the gases like carbon dioxide, sulfur dioxide are more because of the presence of industries. And plants are less. So these are the gases which corrode the metals. Reactive gases such as carbon dioxide, sulfur dioxide, oxides of nitrogen, etc. present in air. Dissolve in water and produce acids. The acids thus form act as electrolytes and accelerate the process of corrosion. This word you will not understand now, but just after 5 minutes I'll give you, then you'll find everything will be as clear as crystal. Process of corrosion. So nothing you have to mark up. Okay. Then presence of electrolytes. See, suppose you have a boat made of iron, or maybe a small ship, which you can ply even big river also. You find rusting of ship takes place faster in the sea than in the river. Why? Because we know sea water is saline. And rusting is an electrochemical process. So due to that, you'll find saline water, the rusting process is faster. That you can do in your house also. Take 2 nails. One you put it in, normal water, whatever you have, you don't have to go for distilled water. Distilled water will not rust. Okay, or you can do 3 experiments. Put one in distilled water, put one in normal water, which you buy, which we drink or we take bath. Another one in a big in a glass you put, and put little bit of salt. You'll find where the rusting process will be faster. That will occur where the salt is there, because you have supplied electrolyte. This is important. From there only the question may come. Why the rusting process is faster in sea water? What they can say? Why ship rust faster in sea water than that of river water? So now we'll go for rusting. So after that, we'll go for mechanism of rusting. Rusting of iron. When a piece of iron is exposed to moist air, it gets covered with reddish brown coating. This phenomenon of deposition of reddish brown coating on the surface of iron by the action of moist air is called rust. The reddish brown coating is called rust and is found to be hydrated ferric oxide Fe2O3 H2O. X. So I'll write the equation 4 FeS 3O2 X H2O. So with that one we will get from air This is moisture. Will give you Fe2O3 XH2O. This is called Mr. Rust. So the question is, why should we have to read rust in electrochemistry? It is a property of iron, then we should have read in D and F block. Why should you read it here? Yeah, this is the most interesting part of it. Okay. Finish writing, then we'll discuss the mechanism of rusting. Somehow you're missing the, I don't know whether you enjoy or not reading chemistry. Okay. But this is the beauty of chemistry. Everything can be analyzed. Okay. Let him dapat depth.
So for depth,
আচ্ছা তো তাড়াতাড়ি করো
Shouldn't there be 2 in Fe2O3?
what dear? Yes, wonderful son. I'll change your name not to one son. Wonderful son. So now one son, you are happily enjoying the home atmosphere, not no? Huh? Good food you are eating. Mother is cooking, no? So now we'll go for mechanism of rusting. Mechanism of rusting. Okay. See here, iron is being oxidized, so it is a redox reaction. Corrosion is a redox process. Sorry. By which metals are oxidized. By oxygen. In presence of moisture. The theory of rusting is called electrochemical theory. In this theory, the process of rusting can be explained on the basis of formation of electrochemical cell on the surface of an iron object. Rusting involves following steps. Now we'll understand. I'll not write much. Done. Okay. So we'll write. Okay, now step one. Don't write. Water vapor present in air. Sorry. Present in contact with iron. Surface. Dissolve. Yeah, dissolve carbon dioxide, sulfur dioxide, etc. from air. See here. This is our surface of the iron. It is not smooth. So water vapor, generally it happens when water vapor gets cooled at the night and it settles on the surface of the iron. You touch an iron object in the morning, you'll find this. You'll find surface is wet. This is the uneven surface of the iron. Water vapor gets condensed on the surface of it. And it comes in contact with the air because moisture has come from the air. So other gases also will come from the air only. So what is going to happen in that case? You'll find that water will dissolve carbon dioxide to give you what? Carbonic acid. Okay, so I'll write now here. This is L and this is G and this is I'm going to write aqueous. Carbonic acid is an acid. It may be weak acid, but still it undergoes dissociation. Okay, so what is going to happen now? H2CO3 will dissociate to give you 2H plus and in equilibrium we have already read weak acids wherein undergoes dissociation, water also undergoes ionization. So I'll write now here L. This also will be H plus aqueous and OH minus aqueous. See, this is the way the electrolyte is being formed. The dissolved carbon dioxide form carbonic acid, which acts as an electrolyte. Now write. Please write iron article, and here you will write water plus carbon dioxide. Step 2. See, enter iron now acts as a anode. Okay. In anodic area means where iron is there, impurity is not there. Oxidation occurs. And iron gets oxidized to Fe2 plus aqueous. So I'll write now here. FeS Fe2 plus aqueous plus 2 electron. Here I'll write anode. Huh?
Yes, sir.
Okay. Now step 3. We have got anode. Now in step 3. See here, like electrochemical cell, now you don't require any metallic wire to conduct this electron because entire body is metal. So this electron we will know now will go to cathode. Who will act as a cathode? It is the impurities. Step 3. The impurities present in iron act as cathode. In cathodic area, electrons reduce oxygen. Oxygen is going to take electron now. Oxygen in presence of H plus ions. Where from you got H plus ions? See here. Here we have H plus ions. Here we have H plus ions. To form water. Okay, so I'll write now here. O2G 4H plus aqueous plus 4 electron will give you sorry 2 H2. So this is cathode. So we know in electrochemicals we know how to write the equation. We write reaction and anode, reaction and cathode. You add it and you write overall reaction. So now we can write thus overall reaction can be written as. Here I'll write this equation here, huh? Because I cannot bend. If I bend more than I develop back. So we'll write now here reaction at N0. So this is the one that I'm going to write. FES Fe2 plus aqueous plus 2 electron. Reaction at cathode. OH plus aqueous O2G plus 4 electron 2 H2O together. See here this is 4, so I have to multiply this equation by 2. I'll add it. This and this will get cancelled. So this is our reaction. Now you can ask me why it is not formed Fe2O3. First it forms ferrous. Then ferrous gets oxidized to ferric. Write down. Step 4. The Fe2 plus ions formed in the overall reaction gets further oxidized. Ions by atmospheric oxygen. In presence of moisture to form rust. Okay. So right now, yeah.
Excuse me, sir.
Yes, sir.
This, Sir, there in the overall reaction you wrote Fe2 plus, while there
Huh?
in the statement you wrote Fe3 plus.
But like, oh no, dear. The Fe2 plus formed in the overall reaction gets further oxidized to Fe3 plus. See, here the oxidation state is Fe3 plus. This is ferrous ferric.
Okay, sir.
Okay. Now first it forms, and as is present in water, it absorbs water. So now I'll write here now Fe2,3S plus XH2O. Get now here Fe2O3 XH2O. But this is also solid. So this is the rust. I don't know in the syllabus whether rust is there or not, present syllabus may not be there also. Please do not follow the thing which is being given in your textbook. It is written in very bad. Now, how to prevent rust or how to prevent corrosion? See, we have already now we know the theory that rusting can occur only when metal comes in contact with the moisture and the oxygen present in the air. See, if I am to stop rusting, if I can somehow cut off the contact between them, then we can stop corrosion or rust. Okay, so prevention of corrosion. That I'm going to discuss, I'm going to write less. Prevention of corrosion. So first of all, we'll try that we'll not allow the surface to be exposed. Metals will be always exposed to air, but this metal surface should not be exposed to air directly. So for that, first one we'll call it barrier protection. That is, we are going to put some substance on the surface of the metal or iron object so that does not direct water and the oxygen gas should not come in touch with the metal, but metal will be exposed. So for that we put a barrier protection. So what are the barrier you can put? Okay, this one you can read, huh? I have already sent. I'll send you also this note. So what we can do? The normal process, we paint it. Moment to paint. Now paint is made up of some colored substances. Along with that, it contains some oily substances. It sticks to the surface. You know, water and oil, they never mix. So in that case, you'll find the object will be there, but surface is not being exposed to the air. So by paint, we can stop. Second, what substance we can use? We can use grease. So grease also will not allow the water to come in contact with the metal object. Okay. we can go for electroplating. When you go for electroplating, what will happen? Another metal you have coated. This metal is found to be less reactive. So we can go for electroplating. You have seen there most of the thing you'll find that you are going to see in case of the automobile parts. We go for electroplating, we electroplate it. You see the bike handle is so shiny, is being electroplated. In that case, we can put a barrier. Now second, we call it sacrificial protection. Very interesting. See, I am to save my iron object. So how to stop this one? We are going to coat it with another metal. Okay. We'll find another metal. Where you find this metal can lose electron faster than iron. In that case, what will happen? This will get oxidized. This will not be oxidized. So we call it sacrificial protection. That the metal which we added, it preferentially undergoes oxidized than that of the metal iron object which is below, and stop oxidation. And this is the most abundantly used process to protect an iron object, and that we generally do by the process of galvanization. So what is galvanization? It is a process to coat iron object by zinc. So what we do? We take the iron object, clean it nicely, and we dip it in the molten zinc. And we take it out and dry it. So that process is called galvanization. See now, very interesting thing. Interesting thing is that, so this is the iron object, okay, and this is being coated with zinc. See now, suppose this portion, because of wear and tear, the zinc has fallen. Zinc coating has fallen. Or there may be some scratch. What will happen? What scratches are, then iron will be exposed. So in this case, this portion is being coated with zinc. So now we know this zinc is going to be oxidized, but this portion is now iron is exposed. In this case, will the rusting occur? See now. Let us try to know. See. The reduction potential, standard reduction potential of zinc is minus 0.76 volt. And standard reduction potential of iron is minus 0.46 volt. So who is going to lose electron? This is going to lose electron. This is not going to lose electron. So we know in this case, this is going to act as an anode. And rusting of iron can take place only when iron acts as an anode. But in this case, zinc is acting as an anode. So even in the exposed area also, the rusting will not occur. See, initially, this iron sheet which you use it for our roof, till now we call it tin. But this is not made of tin. This is made of iron. Then why do you call it tin? Initially, when people did not have any idea of electrochemistry, they used to coat this iron sheet with tin only. Because of that, it is called tin. So these days, if you want to go for buying the iron roof, if you go to the shop, you please tell that I want to buy CGI sheet. CGI. They are called CGI. So C stands for corrugated. Corrugated means what? This wavy. G stands for galvanized. Means it is being coated with zinc. I stands for iron, and we call it iron sheet. So we call it CGI sheet. Even the water pipe, whichever you are using in house, they are called GI pipe. Because water pipes are not corrugated. So it is called galvanized iron pipe. Now, if when initially it was being coated with tin, see what happened. So now, say it is, you have gone around 40 years back. It's been coated with tin. And so portion of the tin has fallen. What is going to happen? See here. In that case, SN2 plus SN, standard reaction potential. Okay. It is minus 0.14 volt. So it is lower. So in this case, you find if this is it is made of iron sheet coated with tin. Moment a portion of the tin has fallen, see here in this case iron get exposed, and now this acts as a anode. So immediately you find the corrosion or the rusting is going to occur. This question often comes. What happens when iron sheet is being coated with tin? Or portion of the iron coating from the tin from the iron sheet has fallen. In that case, you'll find that it will undergo rusting, because in that case, as the electrode potential of iron is lower than that of the zinc, so iron is going to act as anode and it will undergo rusting. So this is called sacrificial protection. Okay. Then we call it cathodic protection. Cathodic protection. Nothing but. You don't worry. What is the cathodic protection? We coat this iron object with another metal whose electrode potential is low, more negative than that of the iron. So in that case, what happens? That metal becomes anode, iron becomes cathode, and rusting does not occur. Okay, same thing we have done in sacrificial protection. But in what type of thing generally we go for cathodic protection? We go for cathodic protection wherever we go for laying the pipes in underground, or you'll find from one country to another, these cables are being put on the seabed. So every time you find it is being totally exposed to the water, and it is the water of the sea or ocean is saline. So the rusting process will be very, very faster. So suppose this is sea water, and this is the cable that you have put. This is the cable. Now, in this rusting process will be very fast. So what we do? In this cable, with the help of a wire, we tie a highly reactive metal like magnesium or aluminum. These slabs we take and we tie it with this wire. Moment you tie, a circuit is being formed. See here now. Magnesium is Mg2 plus Mg. You will be amazed to see its reduction potential is 2.37 volt. So here magnesium acts as an anode, iron acts as a cathode, no rusting takes place. All right. So now, after few months, the magnesium will corrode and will disappear. Then in that case, again rusting is there. So when you put this underground cable, now with the GPS system, now we can locate where are those magnesium. So the divers are being sent along with this magnesium slab, and they go and tie a fresh one. So years after years, this cable can be used and there will not be any rusting. Same thing can be done in your house also. When you lay the pipes, you find after a few days, water gets blocked. Why? Because the rusting has taken place inside the water pipes. So in magnesium, it will be difficult for us to find. Normally, it is difficult for us to find in market open, except in the chemical stores, you will not get it here. So what we can do? We can take aluminum. So you can aluminum, so you can get even in your house also aluminum utensils are there. So if you take aluminum and tie it, roll it against the pipe and put it below, you'll find your GI pipes are not going to rust. In that case, you tell your father, you can have it. Or suppose you made a very beautiful grill in your house, rusting takes place. Once you paint, the beauty of the grill is gone. So some places where it is not exposed to the human eye, you can tie zinc. Zinc rods are there, aluminums are there. If you tie it, you'll find the iron grill will not rust. Now, suppose you have made a monument or a statue of iron, and if you paint it, then beauty gone. In that case, what you can do? We have seen in the final equation, we find final equation, overall equation, what we have written, we have found written there 8H plus. Means rusting is always become faster in acidic condition. So there are some salts. When you dissolve it in water, they make the solution alkaline. And in that case, you will find if you paint these solutions are colorless. Time to time, if you paint, brush it, take this one and brush it over the statue is not going to lose its color, neither is beauty, but you'll find that object will not rust. And the final process is called 4. So protection by anti-rust solution. Okay. So there are some substances are there. So these are the alkaline phosphates and chromate solutions. You make a solution and you put it, you'll find is going to liberate alkali, and the H plus ion which forms during rusting, it neutralizes and makes it neutral. In that case, rusting will not take place. So ultimately, this is the final thing. So I've finished this chapter, and you let me know what chapter I should take it and post it